solve the question and send to me. For any of those of you that cares, we have that opportunity, then we will correct it. Question 1 we have here is define wave. From what I discovered while I was marking your scripts, less than 1/3 of those of you that wrote give definition correctly, despite the correction I made when I was teaching the class. Please, I want to appeal to those of you that are regular. Whatever correction made, please take to it. I told you that definition in marking is either 0 or 2. There is no 1.5. There is no half mark, and there is no 1 mark. What does that mean? We don't mark, you almost get it, it's nearer to it. The rule is you either get it or you score 0. So there are some definitions I managed to mark, but standard marking is 0. While I was teaching you, I told you that waves can be defined as periodic. Check what you put down. That's why I asked you to take your answer sheet, and so that you will mark yourself. I said wave is a periodic disturbance that involves transfer of energy from one point to another in space or medium without causing permanent displacement in the medium. What's the problem? We just say what majority of you give is definition for mechanical wave. You just say the periodic disturbance that involves transfer of energy from one point to another in the medium without causing permanent displacement along in the medium. Yes, that's the definition for mechanical waves. But if you put space in space or medium, that it means you take care of wave through the medium and wave through the vacuum. Is that taken? Please, did you get the definition of wave? Did you get it? Said? You know when you are taught, you are asked to add that to it. So please define waves. Now, suppose you come across question like explain waves. Define wave is different from explain wave. Do you know that? When you are asked to explain wave, you give the definition as given, and you can now say we have types of waves, and you mention some of the types. That's an additional information about wave, and that is when explain the term wave is answered. Definition 2 marks, additional information 1 mark, or sometimes half mark. It all depends on how the mark is allocated, but definition is always 2 marks. Is that taken? So that is that. The second question you are asked to do, in fact that one is even terrible. Now, explain specific latent heat of fusion of ice. Explain specific latent heat of fusion of ice. Yes, what did you put down?
Specific latent heat of fusion of ice can be defined as the quantity of heat required to change the state of the unit mass of water to ice without a change in temperature. It's per kilogram.
Okay. Next person, what did you put down? I will tell you what is wrong with your work. Louder. Again. Can you hear that? Unit mass of water from solid. Is water a solid? Unit mass of water from solid to liquid. Imagine. If you now say water is solid, it's another thing. From water is solid to liquid. And I corrected you when I was treating that in the class. Well, to save time, what do you think is wrong with your definition based on what I said? Anyway, there is one key word that I put, and I told you that you don't find that in any textbook. It's a new development. You can only Google maybe some of the definition in Google will give. And that is melting pond. I emphasize it and I underline it when I treated it. Who was there when we did that in the class? That I said, here talking of ice, melting pond is very important. Were you there? Did you put it in your own? And you got it? Read your own. I will tell you what is wrong with yours.
To completely melt 1 kilogram of ice at 0 degrees Celsius into brackets melting point without a change in its temperature.
Well, his own is far better than definition every other person is given. But what he gave is accepted as additional information. How do we define this? Specific latent heat of fusion of ice can be defined as quantity of heat required by a unit mass of ice block to change it from ice to water at melting point without change in temperature. To change a unit mass of ice to water at melting point without change in temperature. The SI unit of specific unit of fusion is joule per kilogram. You get your 3 marks. Definition 2 marks. Additional information 1 mark. That's how it is called. I use standard of WAEC to mark you, and many of you. I was shocked when I see nobody score 3 under this. Is it that 1 or 2? They score, and it's simple. In fact, I expect you to score the math. The simple question I give to you. That's what is expected. I was shocked. The calculation. How many of you here got the calculation correctly? If you get 6 under question 3, raise up your hand. You get 6 in question 3. That's good. That's good. What did you get in that? Question 3. I expect you to get that too. 150 grams of ice at 0 is mixed with 300 grams of water at 50 degrees Celsius. You have to calculate temperature and take the unit of ice to be 3.36 times 10 raised to 2. And special capacity of water. What this question is saying in essence is that you have ice block. You have ice block at 0. And the mass of this is 150 grams. Then you have water. Water is put in a container. Water is put in a container. Water is put in a container. The water temperature here, temperature of water is 50 degrees Celsius. And this is high. Then you will now drop the 150 into this. So what will happen is that you can now say heat lost by water equals heat gained by ice. That's the physics. You now transform the physics into the expression. How do we get heat loss by water? Heat loss by water will be mass of water, specific capacity of water, change in temperature of water. And that heat gain by ice we now do will be divided into two. The one that will convert it to water at zero, and the other part will raise it from water at zero to water at mixture temperature. So it means the heat gain by ice is divided into two. The one that converts it to with the mass of ice, latent heat of ice, then plus the one that raises it from water at zero to water at mixture temperature. You have mass at ice, so the capacity of water, I can change to water, change in temperature now. So this will now be, if you are reading this and this, at least you get 2 or 3 marks to that level. You have discussed physics to that level. The next you can do is to take your seat. The next you can do is mathematics. You now fill in the gap. The mass of ice, so the mass of water here is 300 grams. Change that to kilogram. You have 0.3 times 4,200 into delta theta will now be 50 minus theta n. That's what you have here. Then this will be equal to 0.15 times 336,000. That's it. Then plus 0.15 times 4200 times, change the temperature now, we have theta n minus 0. That's what you have here. You can now open bracket. This is 3 over 10 times this. That will give you 3 over 10 times this. That's 0, 6, 1, 2 into 50 minus theta n. Sorry, we have this below. 1, 2, 6, 0. That's this by this into 50 minus theta n. That's equal to, multiply this one by, that's 15 times 3, 3, 6, 0. To multiply this by this, then plus 15 times 42 into theta n minus 0. That's what we have. With the aid of your calculator, when you multiply this, what do you have? I multiply this too. 50 times 0. Please multiply this by 50. What do you have? Yes, what's the answer? 50 times 0 is 50. Then? 63,000. You have 63,000. Then minus 1260 theta n equals to 15 times this. It says 50,400. Good. Then 15 times 42.
630.
So you have plus 630 theta. Then 630 times 0 is gone. You now collect the like terms. So to collect the like terms is 63,000 minus 54,400 equals, yes, equals 63, 60 theta n plus 1260 theta L. So what's the difference between this and this? This is 600. What do you say? Equals. Add these two together. 1,890 theta L. Therefore, theta L equals 12,600 all over 1890. So what is that? 6.67 degrees Celsius. That's 6 marks. You get that? I expect all of us to get that too. I expect. Yes. Number 4. Were any question to this? Do you have any question? Explain electromotive force. Explain electromotive force. I gave two definitions when this was discussed in the class. But to my surprise, what I noticed or I saw from the feedback I got from you does not really make me happy. You are mixing the two definitions together. Force was defined as the work done in bringing a unit positive charge from one point to another in an electric circuit, that is, in an open electric circuit. Work done in bringing a unit positive charge from one point to another in an open electric circuit for electromotive force. But you know what some of you are? You said, some will say, work done in bringing a unit positive charge when the cell is not delivering current. That's so common. Work done in bringing a unit positive charge from one point to another when the cell is not delivering current. We take part of the first definition, join it together with the other definition. Nobody is going to take that one right. You want to say work done, it has to be in taking a unit positive charge from one point to another in an open circuit. Okay, you want to give the other definition. Electromotive force is the potential difference across the cell when the cell is not delivering current to external load or not delivering current to the circuit. It's okay. Potential difference across the terminal when the cell is not delivering current to the circuit. It is not work done in bringing a unit charge from one point to another when it's not. That wasn't, and I emphasized it the day it was stated in the class. I thought we would take note of that. Those that got the definition of electromotive force correctly are not up to 3 out of 26 that wrote the test. And it's recently done. To be precise, last week we did. I now wonder what we are learning in the class if what was done last week is asked on Monday and nobody can give me correctly. Now, the next one, you have to explain this. So that's the definition I've given. You can either say work done in bringing a unit positive charge from one point to another in an open circuit. Very simple. Or electromotive force is the potential difference across the cell when the cell is not delivering current to the circuit. Very simple. So that is the definition. Additional information you can add to that is to say that the unit of electromotive and short circuit. That's under electric circuit. You can say there are 3 types of electric circuit. As additional information, then you name them. So the external potential, additional you can give is the unit. External potential is also measured in volts. An instrument that can be used can be voltmeter or potentiometer to measure this. The additional information. I mentioned it that I think one of the students gave us while we were in that class. That student, I don't know her school again. She gave us and we clapped for her 4 properties of waves. And it was after her I made a little modification that we have additional property, but that one is not general. It's not all waves that possess it, which is polarization. But I was sure polarization is what many of us put into your own properties of wave. Despite the fact that you are cautioned that polarization is not general. It's only transverse waves alone that possess polarization. Longitudinal wave does not possess it. And you are warned not to give property that is not general, especially when you have to name 3 or mention 3 properties of wave. You must give what is general. You must give what is general when you are asked to give property. And in your notes jotted in the class that day, we made mention of reflection, that anything that is called wave can be reflected after incident on or after encounter with the surface. Incident on any surface, be it smooth or rough surface, solid or liquid surface, which brings about reflection. Incidents on any surface will bring about reflection. So anything called wave can be reflected. So reflection is a general transverse wave. They can be reflected. We also mention refraction. Refraction is another general. Anything called waves, anything you call wave can be refracted when the wave travels from a medium to another medium of different optical density. When you move from a medium to another medium of different optical density, then you have the wave will be refracted. Anything called wave, whether longitudinal wave or transverse wave or any form of wave, can be refracted. So refraction is the properties of wave. Then we also mentioned that diffraction. Diffraction is another general property. Anything that is called waves can be diffracted. And I caution you, I call your attention to the spelling, how diffraction is spelled. That most of the candidates in the past will write DE for diffraction. That is not DE, it's DIFF. I call your attention to it. Some of you still wrote DE in your own, but of course I marked that wrong for them. Diffraction is another general properties of wave, which you can always give when they say give 3 or 2 or one type of one properties of wave. So then the last one is intervariance. Intervariance occurs in any wave. And what brings the intervariance? You are told that when 2 identical waves travels in opposite direction, when they superimpose, the intervariance may occur, or progressive wave going in the same direction, that's identical wave. When they superimpose, you have constructive intervariance, you have destructive intervariance. And constructive intervariance will occur when the crest of a wave overlap with crest of another wave. That means overlap means superimpose. Crest of a wave superimpose with crest of another wave. Then constructive interference will take place in that case. But similarly, when the trough of a wave superimpose the trough of another wave, we still have constructive interference. But when the crest of a particular wave superimpose the trough of another wave, destructive interference will take place. Be it constructive or destructive, interference is interference. Anything called wave now discover that many of you will put polarization. And you know, the way we mark now is it. When you are to give 3, listen to me. When you are to give 3 properties, you name 1, 2, 3, 4, 5. You are giving 3. The first one you write reflection. Yes, you get it. The second one you write polarization. The third one you write refraction. And the fourth one you write diffraction. And the next one you write interval. Let's say you will write 4. And the examiner say give 3. How we mark is to consider the first 3. We consider the first 3. That's the first 3 we consider for you. The first one will be take right. The second one will not be. The third one will be take right. When you have to mention 4, and you write this like this, you have to mention 4, and the last one you put intervariance here as the 5th one. They will draw line to this and consider the above. So that's what some of you did. This will be right. Instead of 4 now, you get 3. They will not go to 5th one and mark intervariance you put here, even though that is right. Even if they take it right, it will not be counted for you that is called your 4-4. So if they do that for you, it means you set question for your examiner to pick the right one among these. So they will take the first 4. If you are lucky, the polarization you make is the last one, fine. But once it takes any number between 1 and 4, and you have to give 4, they will count it against you. That's the way we mark. Some of you will see you listed polarization, but you are giving 3. You check your script, you understand what I mean by that. And that's, if you score all the mark, I will tell you that I'm not surprised. But the highest I have was 20. The highest I have was 20 over 24 there. So, and it's not good enough. We can quickly, thank God, majority of you here are from Abeokuta South, and you wrote thesis today. Do you have questions for me? B. Yes, you are scratching your head. I hope you are all from Abeokuta South. Let's keep the mock. If you have question on mock, you have. If you have question on mock, hello, you can give me. I will answer that. If you have a question you want me to see. But this one is general now. You are from which school? Ashira High School is under Abeokuta South. So you all wrote physics today. Everybody should have the physics question with. What's your school? And what do I do to check your head? You didn't write physics today. Question is subheaded. They have electricity and magnetism. That's 1. 2, they have waves and optics. 3, mechanics. And 4, thermodynamics. And that's how the branch of physics. The only branch that is not there is the atomic physics. So that was not here. Now, the first question, somebody say 4B. That's under E. Let's quickly run through if time permits us from the first one, which is electricity and magnetism. A part. State and explain Ohm's law. State and explain Ohm's law. State and explain Ohm's law. Yes, who will do that for us? You just wrote the exam today. State and explain Ohm's law. Yes. Anybody from Abel or any other school? State means you are to define Ohm's law and explain it. Anybody? Well, you say question 4B. You didn't give me number 1. Who can define Ohm's law? Yes.
Ohm's law. I got it. South.
Can you repeat what you have just said?
Ohm's law states that the current flowing through a mechanical conductor is directly proportional to the potential difference across the circuit.
Is that all?
Provided that temperature another physical quantities are made constant.
Another what?
Another physical quantities are made constant.
Please clap for me. Even though it's not sure. But I don't know what is happening now. I don't know. We treated electricity before. Even if we don't mention it in the class, I expect senior students to read about. And this thing was defined in the class. During the practical, I reminded you before I said, okay, we are doing the verification of Ohm's law. What I now verified, you cannot say. The Mope, so everybody was looking as if it's a new topic entirely. Ohm's law, which is the basic law in physics, basic law in electricity. Yeah, it is SS1 word, Ohm's law. They said, which of the following quantity do not obey Ohm's law? It's so simple. They put some other material, then they put metal. But it's when you know that the Ohm's law is only applied to the metal, and it's part of what they asked to explain. It's part of what you are asked to explain in the question. State and explain Ohm's law. How do we state it? Severally, I've given it to you, but let me still state it now. You write it down. Ohm's law states that in a metallic conductor, electric current flowing through the conductor is directly proportional. It is directly proportional to the potential difference across the conductor. Provided temperature and other physical conditions remain constant. I don't see a big deal with this. Provided temperature and other physical conditions remain constant. So mathematically we can say V directly proportional to I. And you remove projective sign, you replace with V equals I R according to Ohm's law. This is where V equals potential difference then I electric current and R equals resistance. The other day I gave you quantity obtainable from electric circuit. We discussed this too, the Ohm's law. But I don't know what is the matter. So like I said, what it means is that the law is only obeyed by the metal. It is applicable to metal only. That's why we said in a metallic conductor. It does not apply to electrolyte, and it does not apply to semiconductor and some other material. But in any metal, this law holds. So, and it is only metal that obeys that. And you have resistance. The physical condition affects the resistance of the conductor. And when the resistance is increased, the current decreases. What makes resistance increase is when the temperature of the metal is raised. When you heat the material, when you heat conductor, its resistance increases. And when resistance increases, the current reduces. It lowers the current that flow through the conductor. When the resistance increases, the current reduces. What causes increase in resistance is either you heat the conductor to a higher temperature or you apply pressure. So when pressure is applied on the conductor, resistance increases. And when resistance increases, current reduces. So when we say potential very directly proportional with the current, the larger the potential, the higher the current. The smaller the potential, the smaller the, that's what we call direct proportion. And you can use graphical method to show that it's going to be a straight line that passes when you have like this. You can have a straight line. This may be voltage and this may be current. It's going to be a straight line that passes through the zero. That's the graph of that. So the next one, you work it, everybody, this one. They said B, a resistor of 10 ohm. Resistor of 10 ohm. A resistor of 10 ohms is connected to a 12 volt battery. A resistor of 10 ohm is connected to a 12 volt battery. Calculate the current flowing through the resistor. Calculate the current flowing through the resistor. Everybody works that. You said? I don't say you should cross it. Everybody works that. That's what I say. When you are now done, I will now ask what is the answer. I take the question again. A resistor of 10 ohm is connected to a 12 volt battery. You have to calculate the current flowing through the resistor. Yes? Who is going to answer us? How you arrive at whatever you want to give. Before I pass, please. Number 2 questions, waves and optics. You are asked to define, that's A, define refraction of light as states Snell's law. What is refraction of light? Anybody? Yes.
Refraction of light is the change in direction of the light rays as it passes through a medium of a laser medium to a denser medium.
Again.
Refraction of light is the change in direction of light rays as it passes through a laser medium to a denser medium.
Yes.
Refraction of light is the change in speed and direction of light when light travels from one media to another of different density.
Well, clap for the two of them. second speaker got it right. When you move from one medium to another medium of different optical. The first speaker will say when you move from less dense medium to high dense medium, yes, refraction will occur. Even if otherwise, high to low, refraction will still occur. It's either you move from low to high or you move from high to low. In both cases, refraction will take place. That's why we say we have refraction towards or refracted away. So it is, the refraction simply means change in direction of rays of light when they move from a medium to another medium of different optical density. You can now go further because you have to explain it. So it is change in direction of the rays of light because you are talking of light here. It's still the same way for wave. If they say refraction of wave, it will be change in direction of waves when the wave travel from one medium to another medium of different optical density. That's refraction of wave. The refraction of light here is when the light ray travel from one medium to another medium of different optical density. It will be wrong technically. It will be wrong technically when they say define refraction of light. You now say refraction of light occur when the wave travel from one medium to another medium. They are talking of refraction of light. You are defining refraction of waves. Am I communicating? So technically you should know how to answer. Just like the question I asked you earlier, latent heat of fusion of ice. I have specified the solid, ice. So your definition must be narrow to that solid mentioned. That is, ice is an example of solid I give. So it will now be wrong for somebody to now say required by a unit mass of solid to change from solid to liquid when a particular solid is given to you, so which is ice block. To change ice to water now, that would have been technically correct. So this one too, refraction of light is different from refraction of waves, although the definition is the same. It's only where you put wave, you put light ray. So please take note of all this, very important. Then you have to state Snell's law. You have to state Snell's law. You have to state Snell's law. Yes, who will state the Snell's laws for us? What is Snell's law?
That's the ratio of the sine of angle of incidence to the sine of angle of refraction on a plane is the refractive index.
Take it again.
First law states that the ratio of the sine of angle of incidence to the sine of angle of refraction on a plane is the refractive index.
Not really. Who can define that? Yes.
Snell's law of refraction states that the ratio of the sine of the angle of incidence to the sine of the angle of refraction is constant for individual of medium.
Can you hear that? Please clap for him. Clap for the top because someone is right. I am giving this one to all because it's what we have just done, and I expect you to. So, Snell's law. When we talk about laws of refraction, law of reflection, we have two of them. Law of refraction, we have two of them. I mentioned it in the class. Yes, that's Snell's law. You are now giving a calculated, they said a rays of light. Those of you that don't have the question, you can write it down. A rays of light passes from air. A ray of light passes from air into glass. A rays of light passes from air into glass with a refractive index of 1.5 with a refractive index of 1.5 with a refractive index of 1.5. If the angle of incidence is 30, you have to calculate the angle of refraction. If the angle of incidence is 30, calculate the angle of refraction. I take that again. A rays of light passes from air into glass with a refractive index of 1.5. If the angle of incidence is 30 degrees, calculate the angle of refraction. Who wants to solve that for us in the class? Now, what do you have to say? Any complaint? Okay, clap for her. Well, refractive index is determined by using sine I all over sine R. Very correct. And substitution is on. Then to make R the subject of formula and to get this. But that if it is objective, you get it right. Objective, jam, you get it. But if it is theory, you lose mark. Because I have told you, when you are writing things like this, N can stand for Nigeria, can stand for anything. It does not cause you to say much, to say refractive index N given to this, incident angle I this, then angle of refraction R. Okay, you are not getting unknown. It is after you have defined what each of these symbols stands for, you can use the symbol as used, and nobody queries that. Nobody queries that. But at least he extracted it and started working from the concept. That's good, and that is very correct. Then number three, that's making. You have to define linear momentum and angular momentum. Number 4, you said, may not be treated, because in actual fact, that is not your scope for now. Yes, who wants to define linear momentum? Linear momentum. But we did make needs before we take temperature. Okay, if you don't know linear momentum, what is momentum? Momentum is the product of mass of an object and velocity of the object. Usually we represent momentum as P. Momentum P equals mv. where M stands for mass times velocity of an object. You have that. So you can say P equals mv. That's it. The word linear has to do with straight line. That's an object moving on a straight line. The product of the object, the product of mass of an object and its velocity on a straight line. When an object is moving on a straight line, the product of its mass and velocity is called linear momentum. That's the product of mass of an object. You have angular velocity. And what is angular velocity? Angular velocity is angular displacement. You have angular displacement all over t. Angular displacement all over t is angular velocity. And you can also give that angular velocity can also be written as Lv all over r. V over r is still angular velocity, so which is equals to this. You can turn momentum L is equals to linear momentum all over radius of the circle. You notice that most of the linear something is turned to angular by dividing it then by the radius of the circle. Most of the linear something is converted to angular. Let's see what we have, what I mean by that. When you have V, it's called linear. This is angular. This is velocity. We can say velocity or speed. This one too can be either velocity or speed. Velocity or speed. You have this one as speed. How do I change this one to this? So you can say this is equals to WR. That's the formula. Linear velocity or linear speed is the product of angular velocity times r. Or you simply say V over r equals angular. Look at that. That's it. Displacement. We have linear displacement. Linear displacement, that's equals to x. Then you need angular displacement. This is theta. It's known as angular displacement. Angular displacement. How do we turn linear to? So what we do is to say angular displacement is equals to linear all over radius. You can say you turn linear to angular by dividing linear by this. Or you can turn this one, just multiply angular by r. That will give you conversion of the two. So when we are saying linear, angular, just divide. Once you know the linear, that means if I need angular, I will just divide linear momentum by the radius of the angle to get the angular displacement. So angular displacement is usually represented by L, while linear is represented by P. So we can say P, which is linear, equals angular times the radius of the circle. You know, the body is moving along a circular path. The radius of that circle can convert the linear. We have different expressions you can have for this. The question says distinguish between, you are not asked to even differentiate between linear momentum and angular momentum. All you need to do, you can distinguish by writing their formulas. I can also distinguish by giving their definition. I can distinguish by giving their units. The unit of momentum is kilogram meter per second. And we are talking of angular, that's radian. This one will now give you radian per angular velocity. You can turn this one, anything angular, it has to do with radian per second, the angular velocity. Then you now multiply that angular velocity by the mass, which is can differentiate with that. Now there's a question here. They said the ball of mass 0.5 move with a velocity of 10 meters per second. You have to calculate its momentum. Who is going to do that for us? Calculate the momentum. A ball of mass 0.5 kilogram moves with a velocity of 10 meters per second. Calculate the momentum of the ball. So who will do that for us? The fourth one is out of. You have not been taught and it's beyond your scope. Now let's quickly run through the objective and see how far we can go. Or those of you, you have your mock question here. You have question putting problem to you. Please, because time is gone today. By Monday, if I were you, others that do not write mock in your school, you can get the copy and make copy. But we are going to treat that on Monday during our normal class. So I will take it as tutorial and release some other questions that you are going to practice on Monday. So you come to the class with your mock, and others make sure you're getting the copy of the Abel mock and we solve together. And if need be, you will have gone through the question and mark those ones that you need assistance. Those ones you cannot do or you are not sure. We do it together. Make sure between now and Monday you get a copy of the mock they wrote here. See. Now a body is said to be in equilibrium if dash. A body is said to be in equilibrium if dash. You are given A, it is moving at a uniform speed. It has a constant acceleration. Then C, the resultant force acting on it is zero. Air, water, vacuum, and steam. Which one? Steam. God bless you. So we take the remaining 5 on Monday. Come to the class with your mock questions. Those of you who may query 1 or 2 things, go and read about the topic and come to the class with your own questions. We meet on Monday.